Welcome to the notes for 6.2. This is the first of two videos. We are going to spend 2 days on this lesson 6.2, and so I'm going to do the video in two parts. This lesson is on function transformations, and the objective is to transform functions by translations, reflections, and or dilations. So to start off with, let's go over some vocabulary. So function transformations. Transformations means to change. And so what we're doing is we're taking basic functions and we are changing them into other functions. So if you remember from 6.1, we talked about different function types. We talked about linear, quadratic, absolute value, and exponential. Moving forward, we're going to kind of not worry about linear as much anymore because it is kind of boring, and we're going to add square root. So now as you see, we have our four parent functions that we're interested in talking about. We have quadratic, absolute value, exponential, and square root. So right here we have listed them in their most simple basic form that we're going to work with. And we are going to see how you can make, for example, every quadratic function from this basic parent function of f of x equals x squared. So by transforming x squared, you can make every other quadratic equation. The way you transform it is there's three different ways. You can use translations, reflections, and dilations. And so what do each of those mean? Translations is moving things, so we can move our function up, down, left, right. Reflections is flipping it over. And then dilations is changing its size. So that would be, for example, making it skinnier or wider. So that's kind of the basic idea, that we can take this generic basic function, what we call a parent function, and transform it into every other version of a quadratic, in this case, or absolute value, exponential, or square root. Today we're going to focus on quadratics in this video, and then the next video we'll talk about the other three. All right, so to start, we are going to go to Desmos, and we're not going to go to it the normal way. If you go to Canvas, and right above where you went to the video, there is a link. It says Desmos Quadratic Transformation Activity. So if you click on that link, and it will take you to this page to sign in. Another way you could get to it is if you go to right here, students.desmos.com, and then you type in this code. So if you want to pause and write this down, that's fine, or you can always access it via the link on Canvas. So I'm going to go to the link on Canvas. I'm going to click on that link, and it takes me here. I think it's easiest just to continue without signing in, but you're welcome to sign in with Google if you'd like. Enter your name so I know who you are. All right. Okay, so this is an activity that helps you practice transformations, and it has 16 different problems, 16 different activities. The very first page is basically just for you to play around with the different transformations. So they give you some examples here, and so we're going to just try those examples. So we'll put in one of those equations. So y equals parenthesis x minus c, and c just means a number, so I'm going to pick a number, let's say 2, parenthesis squared. Okay, and you can see, so the black parabola is our original parent function, and then the blue one is this new one that we just created. And the example says it shifts right, and as you can see it did. Our new function that we just wrote shifts it right. So let's go back and see what happens if we do plus 2 instead of minus 2. As you can see, it shifts it left, which makes sense. That's what our example says it would do. And then let's try doing, so go ahead and so play around with this. You can try doing all the different things. It says, I guess I can leave my parentheses there. You don't have to take them off. It works the same. If I do negative, you can see it, oops. I guess I can't scroll on my graph, sorry. Okay, if you put a negative there, it rotates it across the x-axis, or in other words, it flips it upside down. Another thing you can do is you can, let's get rid of the negative, and let's put a number there, like 2, and see, you can see how it's skinnier. Let's try another number. Let's try 10. Oh, it got way skinny. Let's try a small number, like a number smaller than 1. Let's try 0.5. So you see how it got wider. Not very wide. Let's see if we can make it really wide. Let's try 0.04. That's, yeah. So that's really wide. So you can kind of play around with it and see how doing different things affects it. So 0.2. So this page is just here to kind of play around with and see what different things do. Go ahead and try seeing if you can shift it up. That's adding a number after the x squared. So if we add over here, add 5, you can add whatever you want. You can see how it changes it. Add 5, add 3. It's going to shift it up that much. If we want to shift it down, we're going to subtract a number. So subtract 2, could try subtracting 1. So this page here, it's a great way to try it out and kind of just explore and see what happens when you try different numbers. All right, something else you can try is you can try doing multiple things at once. Like, for example, if I subtract 1 inside the parentheses, but then outside the parentheses, I subtract 3. So you can see it moved it to the right, but it also moved it down. All right, so you can kind of see how the transformations work. Right here on the examples, I have listed all the different things so you can see what they are. Let's go back to the notes though. And on the notes, I have a reference guide that lists all the transformations too. And I just want to talk a little bit about how this guide is organized, because you can use this guide as a reference. First of all, some of the transformations some of the transformations are applied inside of f of x, and some of them are applied outside of f of x. And what that means is, in this case, what it means kind of is, so our function, let's get a skinnier pencil here. Okay, our function, our f of x equals x squared. So to be applied inside f of x, that means it happens before we square it. So in our example, that meant we put parentheses around the x squared, and we did it before we squared it. So like x plus 2 squared. That means it's applied inside the function. So the function is squaring it. So if we do it inside the function, it means we apply it to the x before we do the function, which is squaring it. On the other hand, if we're going to apply it outside the function, that means we square it first, and then we do the thing we're going to do. Then we apply the transformation. So that's going to affect it vertically. So if we do the transformation before we square it, it's going to affect it horizontally. If we do the transformation after we square it, it's going to affect it vertically. So that's what these notes mean, whether the transformation is applied inside the function or outside the function. Another thing to notice is this first box. Those are things being added or subtracted inside. The second box are things being multiplied inside. Third box, things being multiplied outside. And last box, things being added or subtracted outside. And they're in this order because technically speaking, this is the best order to apply your transformations in. Most of the times, in the cases we give you, it's not really going to matter what order you put the transformations in. But there are cases where it does matter, and if you do it in the wrong order, you might get the wrong graph. I don't think we're not gonna try to give you any ones that are too tricky, and so I don't want you to worry about it too much. But I do want you to know that technically there is a right order, and in this case, that right order is going to be from left to right. So, from left to right. So just like you'd read, start with the things inside the parentheses and do your adding and subtracting first, then your multiplying. And I know that seems backward from order of operations, but that's just how it works. You do your shifts first that are inside your parentheses, then you deal with what's being multiplied inside your parentheses, then you're going to go outside your parentheses and do what's being multiplied, and then you're going to go outside your parentheses and deal with what's being added or subtracted. If that's confusing, don't worry about it too much. It's not really going to come up too much, but I want you to be aware of the correct order. Another thing, and I probably should have said this earlier, go ahead and cross out this one. We are not going to make you worry about things that are dilated horizontally. Technically, you could multiply something there, but it's usually more convenient to instead write a function with the multiplying it outside. You could always rewrite it in that form, and that's usually how it's written, so that's how we're always going to show them to you. And it's just a neater way of writing it. And so dilating it horizontally would mean to stretch it or shrink it horizontally, and you can get the same effect by stretching it or shrinking it vertically, so that's the way we tend to do it. So cross that one out. Don't worry about it. It does exist, but we don't really use it, and you guys don't have to worry about it. If you notice on the Desmos, we did not have you do any of these. Technically, you could do that on a quadratic equation, but it doesn't really make a lot of sense on a quadratic. So we'll talk about those more in the next video when we do absolute value, exponential, and square root, because they do come up more there. So again, these are the transformations that you might have to deal with. So you can look at your equation and kind of see what they are. So let's go to the example right down here, and I'll explain kind of how to use the table. So describe how each function below is transformed compared to the parent function of f of x equals x squared. All right, so the first function says f of x equals x minus 3 squared. So we look at our chart, that's being subtracted inside the function. So that is right here, it's a shift right. So that's all you have to do is you say it's shifted 3 to the right, or shifted to the right 3, however you want to write it. So that is it. This next one is a picture. So we have to kind of describe it based on the picture. So looking at it, one thing I notice is that it's flipped upside down. And so that is reflected. You could say it two ways. You could say reflected vertically, because it's being reflected, up and down this way. So reflected vertically. Or you could also say that it's reflected over the x-axis. Reflected, if I can spell, reflected over x-axis. Okay, because this is our x-axis right here, and it's flipped upside down compared to that. So you could say either one of those, whichever one tends to make more sense for you. I like to say reflected vertically because that makes more sense to me, but you could say either of those. You don't have to say both. So I'm going to just get rid of the one, reflected vertically. And then the other thing that's happening is that it was moved up. So we'll say it is shifted up by 4. All right. Looking at the next one, so there's a lot going on in this one, so I'm just going to kind of highlight it. So there's a 2 being multiplied there, a 1 being added there, and this -8 being subtracted here. So going in my order from left to right, I'm going to look at what's happening inside my function first. And so inside my function, in this case, means inside my parentheses. So it's that +1. So a +1 means I'm shifted to the left. So shifted left 1. And then, all right, and then nothing else happening inside my parentheses. So I look outside my parentheses and I have that 2. And so that's dilated. So I am, and it's bigger than 1. So I'm going to be stretched by 2. Or you could say stretched by a factor 2. If it was less than 1, I'd say that it was shrunk. And then the last thing is that -8. And so that is shifted down by 8. All right, so that is it. All right, so that is all for the first video. Hopefully that helps. I'm going to go back real fast though to the transformations. If you go through each of these activities, I'll show you how one of these work. They give you a red graph and they want you to try to match it. So what I would do is I'd start with y equals, and then start with just x squared, and I'd put it in parentheses, x squared. And then see, how am I going to change it? All right, so I need to move it left and I need to move it down. So to move it left, I'm going to add 2. Okay, that moved it left, good. And now to move it down, I need to subtract 1. And let's say you got confused and you forgot that you needed to, let's say you thought you needed to subtract 2 instead of add 2. Then you'd be like, oh, wait, wrong way. And then you'd remember that you had to go that way. So it just is going to help you practice making the transformations. And then you got that one. So then you go on to the next one and you practice another one. So that's how the activity works. I think it's a really good practice. So I really encourage you to do that if you didn't do it in class. And as for the homework, so again, this is in 2 parts. So for the homework, it is homework problems 1 and 2 for this first part. And then the rest of the homework problems will be for the second part. All right, I'll see you soon.